Hello, good morning. Assalamu alaikum. How are you? Let's welcome to the class. So let us go for new chapter, control flow instruction. I am uploading the file. So yeah, so this is another chapter, control flow instruction. Actually, basically, we some of the instruction we already use so far. So let's see more details about different types of instructions, control flow instruction, control flow instruction. So one of the first point is flag control instruction. Like we know that there are some flags, carry flag, parity flag, sign flag, direction flag. These are the things, right? So sometimes like some instruction, so we know that after execution of the instruction influence the flags, right? After the execution of any instruction, the flags, they may be set or reset, something like that, for arithmetic and logical instruction. But that sometimes that there are some instructions that are related to the flag only. We can make them set and reset using this instruction. Let's have a look here. For example, if we use LAHF, load AH from flag. So it means what are the flag bits? It will be loaded in AH. So 8 bit, lower 8 bit, not the, because flag is 16 bit. So lower 8 bit, but AH is 8 bit. So load AH, I mean LAHF. So it's together. So that means load AH from flags. It is like that. So that means flag, what are the contents of flag? It will be loaded in AH. Then we can, we can check the different bits. So you know that these are the lower 8 bit, yes, or lower byte of flag. So carry flag, and then undefined, parity flag, undefined, auxiliary flag, and then undefined, then zero flag and sign flag. This is the lower 8 bit. Okay. So by using this instruction, we can load this 8 bit to the AH. Load AH from flag. Okay. Another thing is store AH from flag. Store AH into flags. So that means what are the AH data? It will be loaded in flags. So this is called AH2 flag. And then we also have something like CLC for clear or reset. CL, clear, C for carry flag. So clear carry flag. So whatever it is now will be clear. It will be reset now. So zero will be, carry flag will be zero. We can make carry flag set also, STC, set carry flag. So that means one will be, carry flag will be one. CMC, complement carry flag. So complement carry flag means whatever it will be complement. If it is 1, it will be 0, it will be 0. If it is 0, it will be 1. Then CLI, clear interrupt flag. STI, is set interrupt flag. Okay, and these are the things. So yeah, so what can we see that these are the thing, the special instruction, and there are few more, like, okay, I think it is not in this page. Okay, there are few other instructions related to the flag. Like one is we use it, CLD. So what does it mean? It means clear DF. What is DF? Anybody can remember what is DF? What is DF? Direction flag. And then set direction flag. So STD. set direction of flag. So that means direction flag will be set. Okay, one. So these two also we use it. You will see that one is called CLD and one is called STD. So CLD for clear direction flag, STD for set direction flag. So it's actually particularly they actually affect this direction flag. Okay, but when actually we store AH into flag, so that means it actually affect all these flags, right? Because AH, these flags, whatever they are now, they will be changed according to the AH value. That means carry flag, parity flag, and auxiliary carry flag, zero flag, sign flag, all will be affected. This is like that. Okay, so now let's see an example, like for example, write an instruction sequence to set the current content of microprocessor 8088 or 80, it doesn't matter, microprocessor flags into the memory location at offset mem1. For example, this is the name of the memory location. Okay, so we have to save the flag flag value on memory location. What can we do? We already know that we can copy the flag or we can load the flag values in a AH using LAHF, load AH from flags, right? So flag, whatever the flag bits, they will be loaded in AH. Now we can send it to the memory location very easily. Move the memory location name is mem1. So just directly we can write mem1. Oh, but it's not name mem1. It's called, it's said offset mem1. So offset, so that means memory location offset. So a square bracket mem1 comma ah. So that means it is loaded here, memory. But then what then reload the flags with the contents of storage location at offset mem2. So now from this memory location, from the memory location with offset mem2, this data we have to reload it. So first of all, the memory data we can copy it in the AL and then sorry AH and then AH to flag. So move AH comma square bracket mem2 and then what is the instruction to load AH value into flag? This one, right? Store flag from AH, okay, or store AH into flag. We can say store AH into flag. So that means AH value will be loaded in flag. It's okay? Is it okay? So then actually, like always the data in data segment. So that's why we do not have to, we just write the offset address. That's why it is said mem1 of the data segment. So the offset mem1 of the current data segment. So always actually data in data segment. That's why we do not have to mention that data segment. We just write the offset. Okay, now this one also we use compare instruction. So compare, see, for example, compare, so compare, this is also we use it during to to get the maximum number or to get the minimum number. We use the compare instruction, right? So compare D comma S. So that means how actually it compare? It actually subtract the second operand from first operand. That's it. So D is the first operand, S is the second operand. So D minus S, it is used, right? It happened, but the result is not saved anywhere. Okay, the result is not saved anywhere. So this is called, the compare instruction. What is the difference between then sub D comma H? Okay, if I write sub D comma H, D comma S. So it means this is the subtraction. D minus S happened and the result is saved in D, right? In the first operand. But compare D comma S, it means that D minus S, the subtraction of D minus S is happened, but the result is not saved anywhere. Okay, so it actually I mean after the subtraction, the result, based on the result, the flags are changed, and we actually, the microprocessors check the flag to do some work or to take some decision. All right, so so this is called compare. The process of comparison, let's say the instruction is used to compare two 8-bit or 16-bit numbers. The process of comparison performed by CMP instruction, compare instruction, is basically a subtraction operation. The source operand is subtracted from the destination operand. However, the result of subtraction is not saved. That is, I said, okay. And based on the result, the appropriate flags are set and reset. Yes, some like carry flag will be changed, zero flag will be changed, sign flag will be, so flags will be changed. The status of the flags leads us to understand the relation between the number. You know, like we compare two number to check that is it bigger, or I mean the new one is bigger than the previous one or not, something like that. If you can remember, we use this instruction during to find the maximum number, minimum number. These are the things. Okay, for instance, if 5 is compared to 7, okay, for example, 5 is compared to 7 by subtracting 5 from 7, okay, so D for example 7 and S for example 5. So 5 is compared with 7. So what will happen? So how actually it happened? So 7 minus 5. So that means definitely a small number is subtracted from the bigger number. Definitely there will be no borrow in happen. So carry flag will be reset, right? So zero flag, and also zero flag is reset because the result is not zero. What happened? Zero flag and carry flag both are reset. It indicates that a small number is compared to the larger number. All right. But on the other hand, if 7 is compared to 5, like for example, now for example, we compare 5, we have 5 D in as a D, for example, and S is 7. Now we compare 7 with 5. So how actually it happened? 5 minus 7, right? D minus 5. So 5 minus 7. So we subtract a bigger number from a smaller number. So that means there is a borrow in happen. So for borrow in case, so carry flag will be set, but zero flag is reset. The result is not zero always. Okay. So it results that zero flag is 0 and carry flag is 1. Okay. If both are equal, what happened? If both are equal, like we are comparing 5 with 5, what happened? So result is 0, right? And so that means they can, yeah. So if it is so zero flag will be set. What about the carry flag? Because there is no borrowing happen. So carry flag is reset definitely. Is it clear? Is that okay? Okay. Now it's about that. Now look at here. We may have a negative number. Okay. For example, we compare. Okay. So like we compare five. Let me have it right. 5 with minus 7, for example. We have a negative number. If it is a negative number, what actually we'll do, we just have to I mean for positive numbers, so there is a note I wrote here. For positive number, carry flag is concerned. So carry flag actually, it depends on bigger number, smaller number, carry flag will be set, reset. But for negative number, look at here, if we have a negative number like -7, if we compare like 5 with -7, or -7 with 5, whatever it is, if it is a negative number, overflow flag is concerned. We have to consider the same thing for overflow flag. Okay, we'll discuss the things. So now it is clear to us that what is the difference between sub and compare, right? Sub instruction is the subtraction. It performs the subtraction and result is saved in first operand, right? But compare instruction, it also performs the subtraction, but result is not saved anywhere. Okay. Okay, let's see. Compare -103, 27. That means we are comparing 27 with -103, right? So -103 is -103. So what actually it happened? So -103, then -27 it will happen, right? -27. Okay, so as it is a negative number, we have to consider the overflow flag instead of carry flag. Okay, so now look at here. Now what is the process? If you look at here, so -103, what is the what is the binary value for -103? First of all, we have to get the binary value for 103, and then make the twice complement. We will get the negative number. All right, so it is 100110001. Okay, and what about the 27? So 27 is 0001111. This is 27. So then we perform the subtraction. So what will happen here now? So 1 minus 1, 0. So 0 from yeah. So 0 minus 1, it is not possible. We need a borrow from here. So here also 0. That means we will take a borrow from here. So this becomes 0, this becomes 10, and then we take a borrow 1 from here, it becomes 1, and it becomes 10. All right, so now look at here, 1 minus 1 0. 1 0 minus 1 is 1, because 1 0 is 2 minus 1, and then here also this bit 1 minus 0 is 1, and here it is already 0, right? If you take borrow from 1, it is 0. So 0 minus 1 is not possible. Again we take the borrow from here. So if you continue this way, I think you already know it. If it is not clear, you can tell me. So the result is 0 1 1 this way. Now look at here, this lower 4 bit, and higher 4 bit. So we have there is a borrowing happen from higher nibble to the lower nibble. So definitely auxiliary flag is 1. All right, auxiliary flag is 1. What about the parity flag? Look at the number of 1. 1 1. So 1 2 3 4 5 6. So even parity. So that's why even parity, it is 1. All right. So what about the sign flag? If you look at here, what is the sign flag? So sign flag is MSB bit is 0, so sign flag is 0. What is the 0 flag? Result is not 0, so 0 flag is 0. Okay. So these are the thing easily we can say. So now it's about the carry flag and auxiliary overflow flag. So look at here. So carry flag, as there is no carry out or borrowing happen in the MSB bit, so carry flag is 0. But what about the overflow flag? Look at here, as we are, so as it is a negative, I said in a previous slide, if it is a negative number, we have to consider the overflow flag. So overflow flag is if we subtract a bigger number from a smaller number. And again, what is for the carry flag? That actually applicable for overflow flag also. So if we subtract a bigger number from a smaller number, carry flag will be set, overflow flag will be set. So here, look at here, 27 is bigger than the minus 103. So we subtract a bigger number from a smaller number. So definitely overflow flag will be set. That's the thing. Is it okay now? Do you have any question here? Hmm? Any question do you have here? Okay. Yeah, let's yeah, let me explain it here. So more explanation, like minus 103. So what is the minus 103? First of all, you take the binary value for 103 and make it 12's complement. Then you will get the minus 103. So it is 1001 1001. So it is a negative number or sign number, and then the other operand is 27. So 27 is okay, it is this one. Subtracting the source operand from this, we will do the subtraction here. Okay, and then so why actually I said what I said, actually it is a borrow is needed from bit 4 to bit 3, right? Lower nibble. So this one is the bit 3, right? And this one is the bit 4. So that means we need a borrow in happen from, we need a borrow from bit 4 to bit 3, or higher nibble to the lower nibble. That's it. So carry auxiliary flag is set, and there is no borrow to the bit number 7, but there is no borrow here happen, because 1 minus 0 is sorry, we take a borrow from 1, it was 0. So 0 minus 0 is 0. So there is no borrow for more borrowing happen. So that means there is no borrow happen to the bit 7. So carry flag is reset. All right. What about the parity flag? Parity flag is, there is even number of ones, so it is parity flag is set. The result is not 0. So okay, bit 7 of the bit 7 bit. Bit 7 is 0, so that means sign flag is 0, and the result is produced is non-zero, so 0 flag is 0, because the result is non-zero. But what about the overflow flag? I said that, so shortly what I can say, that overflow flag is concerned if one of the number is negative number. Okay, this is first thing. Then if you subtract a bigger number from a smaller number, you can say that overflow flag is safe. And what actually we can explain it other way, what actually after the subtraction, what is the result? The result is 0 1 1 1 1 1 1 0. What is the magnitude of this binary value, or what is the decimal value? Is 126, and it is a plus actually, because the MSBB digits, so plus 126. Now if you check minus 103 and minus 27, what is the sum of these two? It's not plus 126. That means that this 8-bit is not enough to check the result, because what is the result in a decimal format? It is minus 1130, right? 130 minus 130. Actually the result is minus 130. All right, and if you check, what is the binary value for minus 130? First of all, what is the binary value for 130? What is the binary value for 130? So if you can calculate it, do it, or I am doing it now. Okay, I'm doing it here. 130. So divided it by 2, it becomes 65. then divided it by 2. Okay, remainder is 0. Divided by 2, it becomes 332. Remainder is 1. Divided by 2, it becomes 16. Remainder is 0. Divided by 2, 8. Remainder 0. Divided by 2, quotient is 4. Remainder 0. And then divided by 2 into remainder 0. 1, remainder 0, and then 2, remainder is 1. Okay, so then what is the binary value for 1 0 0 0 4 bit? For okay, so it's 8 bit. So 1 0 0 0 1 triple 0, then 0 0 1 0. So this is 103. So then what is the 2's complement? First of all, 1's complement is 0 1 1 1, then 1 1 0 1. All right, so then if you add with it, okay, if you add 1 with it, so what it will be? So it will be 0 and then 1. Okay, let me check. 1 1 2 3. So is it a 8 bit? 130, yeah, 8 bit. Okay, 1 1 0 0 0 0 0 1 0. Okay, so then it will be 1 1 1 1 0. Okay, look at here. So this is actually we got 0 1 1 1. But if you look at here, this one, but this one is actually 130. Is there any mistake here? 130 6 5 0, then 32 1, 32 1, then 16, then 8, then 4, then 2, then 1, then 0. So 1. So here. Is there any mistake here? Okay, I will check again. I will check again. So anyway, so what is the? I mean, is it? Look at here. The result. If you do this, when actually you do the subtraction, it actually I mean, if you do the calculation, it will be actually plus 126, plus 126. So plus, this is not the correct result. That means actually we need a yeah, this 8-bit is not enough to um, to hold the result. So that's why overflow flag is said. Or simply you can say that as if we have a negative number, overflow flag is to be considered, and if we subtract a bigger number from a smaller number, overflow flag is set. Like 27 is bigger number from minus 103, so definitely the subtraction overflow flag is set. All right, is it clear? Okay, so let's see another example, like move ax comma 1 2 3 4 and move bx comma abcd. So it is a hex value, so as it is a with a letter, msb bit is a letter, so that's why we put a 0. So main thing is abcd. So move ax comma 1 2 3 4 and move bx comma abcd. So compare x comma bx. So that means with subtraction is happen bx from ax. So that means what is ax? 1 2 3 4. And what is bx? abcd. So if you subtract, so abcd is a bigger number than 1 2 3 4, right? So what when actually it's a 16-bit, so same thing, same way for 8-bit also. What can we say? First of all, okay, during the move operation, move ax comma, initially, for example, all the flags are 0. Initially these status flags are 0, for example. Now if you do move ax comma 1 2 3 4, so that means ax will be loaded 1 2 3 4. So that it doesn't change any flag bits. During the move operation, no flag changes, because it's not a arithmetic operation, it's not a logical operation also. Only flags are changed during the arithmetic and logic operation, and some special flag instruction. Okay, so that means no change in here. And move bx comma abcd, there is no change definitely. Now if there will be change if we go do this operation, compare ax comma bx, that means ax minus bx. Okay, 1 2 3 4 minus abcd. Now look at here, if what is the subtraction result is this one. So I mean, few things we can directly write, like look at the number of 1. How many number of 1 here? 1 2 3 4 5 6 7 8 9. So it is odd parity, so definitely parity flag is 0. All right. Oh, what about the overflow flag? Overflow flag, because here no negative number. One is 1 2 3 4, one is abcd, so no negative number, so overflow flag is, you can directly say it is 0. Okay, now about the auxiliary flag. Auxiliary flag, look at here from lower nibble. This is 1 1 0 1, and here it is 0 1 0 0. So which one is bigger? 1 1 0 1 is bigger than 0 1 0. Definitely you need a borrowing from the next nibble, from the next higher nibble. Okay, because here this 4 bit is 0 1 0 0 and this 4 bit is 1 1 0 0 0 1. So 1 1 0 1 is bigger than 0 1 0 0. So definitely auxiliary flag will be set. Okay, what about the carry flag? Look at here. So the carry flag will be set also, because we subtract a bigger number from a smaller number. That's why carry flag is set. And what about the sign flag? Look at the result. MSB bit is 0, so sign flag is 0. What about the 0 flag? Result is not 0, so 0 flag is 0. Is it clear? Is it clear? First of all, you have to do the subtraction. So what is the result? Because the result, looking the result, you have to determine the parity flag, and rest of the thing actually without looking the result we can do it. Yeah, this sign flag also you have to look at the result sign flag, because MSB bit is the sign flag. Okay, and number of one determines the parity flag. Okay, but about the overflow flag, auxiliary flag, and carry flag, without looking the result, we can tell, we can say. So, for example, auxiliary flag, auxiliary flag. Why it is said? When it is said, if we have a carry in, okay, borrow in or carry out happen from low, from on lower level from next level. So look at here, as we are doing the subtraction, and this lower nibble is 1101, and this lower nibble is 010. So we subtract a bigger number from a smaller number. Definitely a borrow, you need a borrow. So that's why auxiliary flag is said. What about the carry flag? Carry flag is also, we can say, without looking the result, we can say, because we subtract a bigger number from a smaller number. That's why carry flag is said. Is that okay? Any question do you have? Okay, so yeah, then we, well, okay, before we go to here, so if we have a, like, if we do the I mean perform some operation like arithmetic operation or logical operation, that actually affect the flags, arithmetic and logical operation that actually affect the flags. Also some special instruction related to the flags that we discuss in here in this space, they also directly affect the flags. Like we can set the carry flag, we can set the flag using some special instruction like CLI, clear interrupt flag, STI, set interrupt flag. I also said CLD, clear direction flag, STD, set direction flag. So they actually, it doesn't this instruction is related to the flag bits only, directly related to the flag. They directly make them set or reset by using the instruction. And like CLC, clear carry flag, STC, clear set carry flag, CMC, complement carry flag. So, and also yeah, these are the thing, these two instruction like load flag into AH or store AH into flag. So these are the special instruction that actually affect some flags, but otherwise it needs arithmetic and either arithmetic operation or logical operation. Okay, but move is not a logical operation or arithmetic operation. Okay, move is not a logical operation or arithmetic, so there is no change in the flags. Okay, that's why, like, for example, if you look at here, so these exercises, for example, initially all the flags are 0. This is, for example, they are all 0. Now if we have an instruction like move AX comma 1 2 3 4, because there is no logical, it's not logical, it's not arithmetical. Okay, there is no arithmetic operation, no logical operation, so no change. Whatever they were, they are now same. Move bx comma abcd, it is also same, but compare ax comma bx, it actually do the subtraction. That means it is a arithmetic operation. The flags are changed according to the result. And looking the we have to look at the result to determine the parity flag and to determine the sign flag, because sign flag is related to the MSB bit and parity flag is related to the number of ones. Okay, but other thing actually, without looking the result, we can directly say without looking the result. Okay, this is the things actually, but we need the binary value. like binary value. We need that because when actually we do the comparison, we need the binary value for the data, because sometimes the value we put, it may be hexadecimal or it may be decimal. So if it is hexadecimal, we can write it binary value easily. But if it is a decimal number, we have to convert it to the binary value. Okay, like the previous one here, like the previous one here. So minus 103 comma 27. So that means you are comparing minus 103 with 27. What is the minus 103? First of all, what is 103? And do the twice complement. It will be minus 103. So this one is the minus 103. So then minus 27, minus 27. So 27, this is the 27. So then we do the subtraction, but you know the parity flag. So we have to look at the we have to look at the result to check the parity flag. Is it a number of one, is even or odd? But what about the overflow flag? I say if we have a negative number, overflow flag is concerned. Here we have a negative number, so a overflow flag is related here. But you know that then if you subtract a bigger number from a smaller number, overflow flag is set. Okay, so without looking the result, actually we can say. Then what about the auxiliary flag? Look at the lower nibble. Look, this lower 4 bit, lower 4 bit here, lower 4 bit, lower nibble is 1001, and here lower 4 bit is 1011. So which one is bigger? 1011 is bigger than 1001. So definitely we need a borrow. We need a borrow from next higher nibble. So auxiliary flag is 1. Is it okay? So without subtraction, actually we can tell it. What about the carry flag? Carry flag also, you know, we can we have to check the result. Yeah, for here actually for the carry flag we have to check the result, because you know yeah, because as it is a negative number, we have to check the. And sign flag also we have to check the result. Yeah. Oh, no, carry flag. Without looking the result, we can tell it, because you know, like 1001. So 1001, 1001. You are subtracting 001, 1. So this one is low. This one is lower than this one. So definitely carry flag is reset. There will be no final borrow in happen. So carry flag also, without looking the result, we can tell. Zero flag also, because they are not equal. So only we have to check the result. We have to look at the result for parity flag and sign flag. Clear now? So two examples here: negative number and sign number. And yeah, so is that okay? Try to understand these two example. You know what are how actually the flags become set and reset based on different kinds of different arithmetic and logic instructions. Like one of the arithmetic instruction is compare. So this is also same thing for subtraction also, because subtraction also do the same thing. So yeah, that's it. So is that okay, right? So this Thursday you have measure 1, right? You have measure on this Thursday, so at 12 o'clock. So I will upload it on the Blackboard, and time is 1 hour 30 minutes. So nothing will be accepted on email. Okay. So you have to finish it on time yeah, and submit it on the Blackboard also. So yeah, so this is the thing. So if you have any difficulty related to the technical issue, you have to send me email immediately, okay, during this time, within a like 10 minutes or 15 minutes. Otherwise, you will not be considered. Any other excuse will not be considered. Okay, so 10 to 50, within a 10 to 15 minute question, I'm not sure you will get it on the exam time. So yeah, so you can, so handwriting is the thing. So no typing or nothing. So I just write it on your paper and upload it on the blackboard. That's it. Okay, so handwritten. So you can yeah, yeah. Okay, so this is the thing. Is there any other? Okay, so yeah, so that's the thing. Hopefully, and yeah, so within a 10 to 15 minutes, you have to send me email if there any issue you have. Otherwise, it's not, it will not be considered. Okay, and no email attachment, only blackboard attachment will be considered. So these are the things. Yeah, and yeah, write your name on the on the answer paper. Write your name and ID. Without name and ID, actually I cannot follow it. Okay, so name and ID, you must have name and ID. And what else? Yeah, yeah. So this is the thing, and it's a closed book exam. Don't try to cheat, even if I am not looking you. So I mean, someone else is looking you. Okay, so you know it. So try to be honest. And there is nothing to. I mean, it's not a open book exam. It's a closed book exam. So it's not allowed to open the lecture note or book or anything. So yeah. So that's it. That's it. So do it whatever you know. Write it whatever you know. Okay. Do you have any question related to the exam? Question. Okay. All right. So see you in the